Hi folks, welcome to day 14. Today we're going to be working on how to solve equations that have rational exponents and radicals in them. So this is primarily going to be a video with examples, with a few points before we get going. So a few things I want you to remember is that anytime you are working with solving an equation, right? You have like x plus 4 equals 2, right? It's really important to remember that what you do to one side, you must do to the other. So you have to do it to the other side. Alright, so in this case, we would subtract 4 from both sides. But when we're getting into it, it's going to be like squaring both sides, cubing both sides, raising both sides to the 4/3 power, something like that. All right. And the other thing to remember is that the opposite of a rational exponent, right? If I wanted to eliminate that, I would maybe that's like, I don't know, maybe it's equal to 27. All right, doesn't really matter. So what we'd have to do if we were trying to get rid of this 3/4 power is you have to raise both sides to the reciprocal power. So reciprocal meaning you flip the fraction. So we'd raise both sides to the 4/3 power. And then after we did that, x gets by itself because those cancel. Right? Because 4/3 times 3/4 is just 1. So using those properties of exponents, we know that that multiplies, so that's just 1. And then we would rewrite our right half as an nth root. So you can see my root is 3, so I have a third root of 27 raised to the 4th power. The cubed root of 27 is 3. 3 to the 4th power is 81. All right, so you can see, like, the reason why we do this is because it simplifies down a lot. And I know I walked through that one really, really quickly. I'm going to go through another one, and I'll go through real slow. All right, but those are, like, the two things I want you to remember with this is what you do on one side, you have to do to the other, and how you get rid of a rational exponent or a radical is to raise it to the opposite power, right? So in order to get rid of a square root, you square both sides. If you're trying to get rid of a cubed root, you cube both sides. All right? So let's go ahead and try out some examples. So if we have something like x to the 2/3 is equal to 4. All right? If that's our job is to try and simplify that, solve for x. We're always trying to get x by itself, so that means in this case, we're going to go ahead and use that same trick I just showed us. Instead of 2/3, we're going to raise it to the reciprocal power, so you have to flip the fraction. All right, so what's a flipped 2/3? Well, instead of 2/3, it'd be 3/2. All right, when we do that, those cancel, so we get x by herself. And we have 4 to the 3/2 power. All right. And when we do that, so we know we're going to want to turn this into a radical so we can actually work with it. What's on the bottom is in the denominator. That's our dirt. That's in the dirt. That's with our roots. All right. So our root is 2. It's a square root. So since it's a square root, we don't have to write that little 2. But it's the square root of 4 cubed. All right. Square root of 4 is 2, cubed is 8. All right. Technically, this is plus and minus 2, but plus 2. So I guess, technically we could write a plus and minus there, but same concept. All right. So that's just one of our examples, all right? But you can see that every time that we're going through these examples, we're always trying to get x by itself, all right? So that was an example with an exponent. Let's go ahead and try an example with a radical. All right, so we have 2 times the square root of x plus 1 equals 4. And you can see anytime that I'm working with square roots, I always put the little end part on it because that reminds me, hey, that's where the square root ends. You don't have to do that, but it is useful. All right. So my recommendation when you're working on these is basically think about PEMDAS, but go in reverse order. All right. So when you're trying to simplify, if this had like a +2 on it, we'd go in reverse order and we'd want to subtract first. All right. So because of that, we can't get rid of our square root yet, which would be in the exponent part or the parentheses part, depending on how you write that. All right, so we can't get rid of our square root yet because it has that multiplication of 2 here. So what we're going to have to do is we're going to first have to divide by 2. All right, and remember, you're going in reverse PEMDAS order. That's how we know we have to divide by 2 first. We have x plus 1. Square root of x plus 1 equals 4 divided by 2, which is 2. All right. Now we're going to go ahead and get rid of this square root. We do that by squaring both sides. So we're left with x plus 1 equals 4, subtracting 1 over on both sides. So like once you get rid of the radical, or you get rid of that power, that exponent, that's when you can go back to normal PEMDAS, which is why we're going to go ahead and subtract this over. All right, so then we have 4 minus 1, which is 3. All right, so that's the end of that problem. You always know you're at the end when you go through and you're like, oh, hey, that's a nice number. All right, let's go through another one. This is going to be the hardest type you'll see, which is why I want to walk through one. So the square root of 44 minus 2x equals x minus 10. So when we have ones like this, we're trying to get that radical by itself, right? That's your first step, is get the radical by itself, so that way you can undo the radical. So that's what we're going to go ahead and undo. What we're going to go ahead and do now is undo this radical by squaring both sides. But keep in mind, when you square the right side, this now becomes a binomial, so that means you're going to have to FOIL. So our left side, we have 44 minus 2x. Then our right side, we have x minus 10 times x minus 10. All right, we're going to go ahead and FOIL that. I'm going to skip a few steps here because I write them out in my written notes. All right, we get x squared minus 20x plus 100. Then we want to get everything on the same side. So we're going to subtract 44, and we're also going to add 2x. The reason why we want to do that is because if this can't factor, at least then we can use the quadratic formula. But hopefully this will factor, but we won't know if it'll factor unless we actually combine everything on one side. All right, but sure enough, it does factor. And here I see that my b value is negative, my c is positive, so I'm going to just look at my negative c values, my negative c factors, because I know that those are going to add up to be negative numbers. So I have -1 and -56, which adds to be -57. I have -2 and -28, which adds to be -30. -4 and -14, adds to be a -18. And our last one's -7 and -18. Or sorry, -7 and -8, and that adds to be -15. So that means that the ones I'm going to be using are this -4 and this -14. So I have x minus 4 and x minus 14 as my two factors. To solve them, all we got to do is set each factor equal to 0, all right? That's why this is really nice, because it's super easy. So you have x minus 4 equals 0 and x minus 14 equals 0. All right, so that means we get x equals positive 4 and x equals positive 14 as our two factors. All right? I do have a couple of more examples in my written notes, but I'm trying to keep my videos a little bit shorter for y'all. So make sure you're reading through my examples in my written notes. These might be a little tricky. That's okay. Make sure you're referring back to those properties of exponents that you wrote down yesterday in your notes from yesterday, okay? So write down the properties of exponents and radicals if you haven't already done so, and then go ahead and try out my problems. If you get stuck, make sure that you are looking at my written notes where I have like an extra 3 or 4 examples for you to try out. All right, your book also has tons of examples. Other than that, best of luck to you. Email me with any questions.